Hey class, this is Mr. H. Going to continue with 2.4, talking about a little bit of interpreting of the standard deviation. So we're on page 13 of the chapter 2 notes. Remember what standard deviation measures? It measures spread. So how spread out is a data set? Okay. A larger standard deviation would indicate something is more spread out, right? So if you looked at a graph, maybe, something that had like a real spread out distribution would have a larger standard deviation, where something that was really centralized, those are really bad drawings, but get the idea, more centralized towards the mean, smaller standard deviation, okay? And then if all data values are equal, there's no deviation at all from the mean, right? Because all the values are the mean, so the standard deviation would be 0. Okay, which would be the lowest standard deviation you could have. You will never have a negative standard deviation, right? Okay. The highlight of this video is going to be this empirical rule. It's also called the 68, 95, 99.7 rule. And it talks about populations that have a symmetric bell-shaped distribution, right? So this rule only works if you have that shape in the population, okay? If that's true, if your population is bell-shaped, then we can talk about the percentage of data values within a certain range. Specifically, here, the first rule, 68% of the entire population is going to lie within 1 standard deviation of the mean, okay? And since it's symmetric, then we could even break that down further. 34 is on the lower half, right? X bar minus the standard deviation, and then 34 above, adding the standard deviation, okay? Continuing, there's another rule, 95% of the data lies within 2 standard deviations, right? So there it is there too. So that's from here to here. 95% of the data will lie within 2 standard deviations. You can even break that down further, because if from here to here is 95 and here to here is 68, then 95 minus 68 is something. What's that? 27. And then 27 divided by 2 is each of these guys. Right? But you could just use this handout. I mean, if you're wondering where these numbers come from, I'm just talking it through. Okay. And then you can continue with even more. You have this 99.7% rule for 3 standard deviations. And then you can break it down. Similar, you get those little 2.35s for those little sections. And since this graph goes on forever in both directions, like we're not going to stop at 3 standard deviations, it's going to go more. This is, I'll tell you, is 0.15%. So it's a really small amount. But, and over here too, 0.15% for that little section. Okay, what happened there? Okay, and so you can use these, and it probably makes no sense right now what I'm talking about until we get to an example. It'll help. Okay, so let's do an example and we'll refer back to this table, okay? So, in an example or a survey conducted by the National Center of Health Statistics, we have a sample mean for the height of women in the US that are in their 20s, 64 inches. So, I'm going to write this down over here. Mu is 64. Right? Mu meaning the, it does say sample mean, doesn't it? Oops, that's the wrong symbol then. Sample mean, X bar, is 64. And a sample standard deviation of 2.7, that's an S. Okay? Use the empirical rule to estimate the percentage of women whose heights are, okay, so we're going to do an estimation of percentage of women or percentage of data values whose heights are within some sort of range, okay? And then we have these values. What I would recommend on these problems is to draw your own bell-shaped distribution, but instead of all of these X bars and S's and all this down here, use the numbers that have been given in the problem and mark them out. What I mean is, okay, so I'm gonna draw my little bell-shaped distribution over here, give myself enough room. There we go. Whoa, that got a little wobbly, got nervous. Okay, the middle is 64. All right, that's the mean. One standard deviation above the mean. What is the value of one standard deviation above the mean? That's an addition problem. 64 plus 2.7. That would be, was that what it was? 2.7, yeah. So that's 66.7. Right? That's one standard deviation above the mean. Two standard deviations above the mean would be add 2.7 again. That would be 69.9. No, it wouldn't. 68.9. Right. Adding 2.7. Add 2.7 again. We're kind of running out of room here. Adding 2.7 to that would be, what is that? 71.6. Let me do it on my calculator so I don't mess this video up. 71.6. Okay. That's 3 standard deviations above the mean. You could also go below the mean, below 1, below 2, below 3. Okay, and I'm just going to be subtracting that 2.7. So that's going to be a 61.3. Subtract 2.7 again. 58.6. And subtract 2.7 from that. 58.6 minus 2.7 is 55.9. Okay. These numbers, once you calculate them, will be crucial and very helpful in answering these questions. All right. Okay. So let me double check this. What did I do this one? 64. Yeah. Okay. I did mess up, didn't I? I knew I did. Didn't feel right. Okay. I'm sure you've already caught on to this. Those aren't right. Okay. If I add, addition is hard. 66.7 plus 2.7 is 69.4. Okay. And then 69.4 plus 2.7 is 72.1. There, do you feel better now about your teacher? Okay. Okay. There, those are the right values. Sorry about that. Now let's get to the problems. Okay. What percentage of the women would be between 61.3 and 66.7? Now, like all of these questions should have numbers on my graph here. There's 61.3 to 66.7, right? So if I want to get fancy, I could maybe draw this. I'm really after what is that area. And notice those are each 1 standard deviation away from the mean. So that's that 1 standard deviation rule. Right? About 68% of the data lies within 1 standard deviation of the mean. Okay, so my answer to this one would be 68%. Okay. How about between 58.6 and 69.4? Okay, so I can erase that and let's try that one. Oops, sorry, let's do orange or something. Okay, so 58.6 to 69.4. I want to know what that area is. All right. Each of those numbers are 2 standard deviations away from the mean, 2 standard deviations below and 2 standard deviations above, 2 intervals of 2.7 in either direction. okay? So if you look back above, that 2 standard deviations rule is 95%, all right? So my answer for B is 95%. Okay. Next, between 64 and 69.4. Okay, so let's clean this up. And I'm gonna go pink for this one. 64, 69.4, that area there, right? Well, 64 is the mean, and 69.4 is 2 standard deviations above the mean, but not below, right? So it's, if it were 58.6 to 69.4, that would be the 95%. But this is just half of that. So I could do 95% divided by 2. Just get half of that, right? So this one, my answer is going to be 95 divided by 2. 47.5%. All right. Another way, notice you have these 2 columns, right? So you could just go up to the top and just look at those 2 columns and just add those 2 numbers up, right? That would be the total of 47.5 as well. So there's an alternative option. All right. Cool. Okay. Clean up. How about less than 58.6 inches? All right. So where's my 58.6? There it is. I see it. Let's do the yellow. It's that little area right there, right? Less than 58.6. Okay, so I could go up, let's see, 58.6 was 2 standard deviations below, right? 1, 2 standard deviations below. So that's right there. So it's really this area right here, right? That I'm talking about. So that's adding 2 areas, 0.15 and 2.35. That's how I could do that one. Okay. So if I do 0.15 plus 2.35, 2.5%. The final answer on that one. That was the final answer. I should circle my answers. Okay. And then finally, the last one, more than 72.1. Okay. Oh no, I just erased my. Okay, more than 72.1, that's really in that little tiny area over there. It's that little thing. Okay, more than 72. 72.1 is 1, 2, 3 standard deviations above the mean. Right. So 1, 2, 3 standard deviations. It's this area right here, which we already know. That's that 0.15%. Okay. So my final answer is 0.15% on that one. Don't worry too much about where these percentages are coming from. We'll get to that in chapter 5 and 6. But right now, you're just kind of taking them for what they are, using that table or that chart there to figure out those percentages. So always go back to this Bell distribution to find those percentages, and you'll get the right answers. Okay. And I think that's it. Yeah, the next is 2.5. So that gets you through 2.4. If you have any questions, send them my way. Hope all's well. Talk to you later. Bye.